Hello, people who love organic chemistry. Chapter 13. So now we're doing crazy stuff like double bonds and triple bonds and all kinds of fun stuff. Okay, alkanes are saturated. What does that mean? Mostly it's when people who don't know anything about chemistry talk about chemistry and they use things like saturated and unsaturated and polyunsaturated and all kinds of big words like that. Saturated. What does it mean? It means they have as many hydrogens as possible. I swear I can spell possible. Is it changing my hydrogens? Okay. They have as many hydrogens as possible. So what does that even mean? Okay, if I have one of these guys, it's saturated. All of its little bonds have hydrogen on it. What does that mean? This guy is saturated. Oh, he's not saturated. He's missing a hydrogen right there. Okay, now he's saturated. All of his carbons have hydrogens. What does that mean? Well, it means there's no double bonds, because what do I have to do? If I want to make this a double bond, right? What do I have to do? I have to take off this hydrogen. I have to take off this hydrogen. And I have to bond them together. Right? So now I have a double bond right here. Look at that. Ooh, double bond. There it is. Maybe I have a double bond. These are much harder. I really do have a double bond. Okay. Okay, now I have a double bond. See it? See how pretty it is? But what just happened? I lost two of these pretty hydrogens, right? This hydrogen had to come off to make this double bond. Can you see it? This hydrogen had to come off. So now it is unsaturated. It is not saturated with carbons. I mean, it's not saturated with hydrogens. Because of my hydrogen, I had to take it off to get this double bond. So alkanes, which don't have any double bonds, are also considered saturated. They're saturated with hydrogens. They have as many hydrogens as possible. Unsaturated are unsaturated if they contain double or triple bonds. So there are less hydrogens. Okay, so that is just saturated and unsaturated. We'll talk about that more, especially when we talk about fats and digestion. We'll talk about saturated and unsaturated. Alkenes are hydrocarbons that contain double bonds. Alkenes contain double bonds. I do not know why I did not put this in your notes, but we're going to write it anyway. Alkynes have triple bonds. So just write that in your notes. Alkynes have triple bonds. Now, the good news is the naming of this stuff is mostly exactly the same, except instead of propane, you're going to propene or propine, depending on if it has a double or triple bond. So the naming rules don't really change all that much, except for the ene and the ine, which are not really that big of a deal. So let's go over them again, because it's so fun the first time. So name the parent compound. So you're going to do the same thing. You're going to do 1, 2, 3, 4, 5, and you're going to say, okay, that's instead of pentane, it's going to be pentene because you have an ene, because you have a double bond. The same thing, 1, 2, 3, 4, 5, 6. You have, instead of hexene, you're going to have hexine because it has a triple bond right here. Now, one other little rule you have to remember is you can't skip it and make it a group. You have to include it in the parent compound. So here you could do 1, 2, 3, 4, 5, 6, 7 and make this like a group. You can't do that. If you're naming it, this has to be included in the group, and then this has to be the side chain. So in this case, the name is hexene, which is the 6 carbon ring containing the double bond. Okay, so we have done that. You are naming the parent compound. The second step, number the carbon atoms. So we're numbering the atoms so that you have the main chain that we just named the parent compound. You have to include the double or triple bond as the lowest possible number. So in this case, we're not naming it this way. 1, 2, 3, 4, 5, 6. We're naming it this way. 1, 2, so that the double bond is 2. The same thing here, 1, 2, 3, uh, the reason we're doing this is so that both because it goes 1, 2, 3 the other way, is so both the little methyl group here and the double bond have the lowest numbers possible. It's a little bit like, it doesn't take long, but you have to actually think about it, which way would make the numbers the smallest. The same way here, the trump is the triple bond. So you're like, oh, well, this methyl group would be 2, but you have to make the triple bond 2. That's the most important thing. So 1, 2, 3, 4, 5, 6, 7, 8, and then you have the methyl group here. Okay, cycloalkenes. So these are possible. So we can have things with a double bond. However, the triple bonded business is very difficult. We'll talk about that, but there's only really one type of that. But there can be a double bonded cycloalkene. You just have to name it. You just have to tell me where that double bond is. And again, the same naming principles apply. You have to make that double bond the smallest number. So in this case, you would name it 1, 2, 3, 4. Don't start where the methyl group is. Start where the double bond is. Write the full name of the whole thing. So here we have the parent name is pentane, and you have to put where the double bond is. So in this case, it's 1 pentane. In this case, it's 2 hexyne, because you have a triple bond. In this case, do you remember this one from earlier? 1, 2, 3, 4, 5, 6. And then you have a propanyl group. So that's on the third. 3 propanyl, 2 hexene. It takes a little time. You do a few of them, you get used to it. Just fill in the rules. It's not horrible. It's just getting used to naming them. You will have to do them on the test. Some of them will be matching. Some of them I will give you the name and you have to draw the compound. Some of them I'll give you the compound. You have to draw me the name. Okay, let's talk about alkenes and alkynes. Differ from alkanes in that I sort of just said this. They have multiple bonds. There's no rotation around the bonds because they are rigid. Write the word rigid. As a consequence of the rigid nature, they possess ends and sides. Ends and sides. Yeah. So what does that mean? They have ends and sides. What in the world? Okay, so I made some of these awesome things for you earlier. Okay, so here's what I've got going on. Here is my alkane, right? There's no double bonds anywhere here. And look at these guys. Ooh, I can do whatever I want. I can have them go in like this crazy zigzag. I can put them like this, where the 2 blue ones are like knocking on each other like this. I can move them like this. I can move them however I want, right? Because they're single bonded. I can just move them around. It's super fun. I can play with them all day, right? That was chapter 12. Now we're in chapter 13. Boom, double bonds. Oh, I can't move anything. It doesn't move. So now it matters. So now I have these guys, right? My double bond right here. I'll hold it by the double bond, or then you can't see it. Okay, I'll hold it like this. There's my double bond, right? Oh, there's my double bond. Now this matters. So see, now I have these guys up at the top because I can't move them. That is actually different than these guys. Do you see how this is going to chemically be different? Because you got these guys kind of knocking to each other, and then you have these guys who are kind of far apart from each other. Different. Cis and trans right here. So there's sides and ends. That's what I'm talking about when I say sides and ends. Now you have cis and trans isomers. So here's my cis. Here's my trans. The way I remember this, cis has sides. They're on the same side. Cis has same side. So same side. Trans is on opposite. It has a T in it. I don't know. You can think of something catchier than that and let me know, but that's all I have. They are on the same side. Trans are on opposite. Opposite sides. So that's how you remember the cis and the trans. And this is also going to help you write them out. If I need you to write them out, I will give you whether it is a cis or trans. Or if I want you to make them out of these super fun little things. It took me a really long time to make those, by the way. That's for you. Okay, so now we sort of know what cis and trans are. We need to play with that a little bit more. We'll do that in lab or class or whatever. The two substituents that are on either side of the double bond and alkene are said to be cis to each other. So I'm just repeating what I just told you in case you didn't get it the first time. Cis, the opposite side, are said to be trans. So if you're naming something, the terms cis and trans actually have to be in there once you get to alkenes and alkynes, because this is a different molecule than this. They're going to behave chemically different. So if I want you to write to pentane, I have to tell you whether it's cis or trans, which I will, because I love you and I want you to know these things. Okay. Vision. Okay, this is a little brief trip through physiology, because we'll talk about it again. The things that I actually want you to kind of remember from this, so that it's not completely new information, is that you have vitamin A. The vitamin A is an organic molecule. It creates beta carotene, which is a purple-orange alkene that provides our main source of vitamin A. Now, this is why people get blindness, night blindness, when they don't have enough vitamin A. So you need vitamin A. In the eye, vitamin A is oxidized to retinol, which undergoes cis-trans isomerization. Ha! We just learned about isomerase. What isomers were? Yep. Okay, so rhodopsin is what gets made into opsin. Sorry, so I paused it, but now I'm back. Rhodopsin gets made into opsin. When this chemical process happens, you can actually bleach out your rhodopsin, and all your rhodopsin is made into opsin, and you can't see anything else. It's really cool. I have some visuals on Moodle that you can look up, and you can bleach out your rhodopsin pathways. It's really fun. We'll do it in class too. And so this is just some material on that, because we will talk about it in physiology. Okay, let's try and get this done in one lecture. So, polymer chemistry. So a polymer is a large molecule formed by repetitive bonding together of many smaller molecules called monomers. So what you have, monomers, hold on. Sorry, I'm back. Okay, so these are two monomers. Two little monomers, and they can come together and make a polymer. So smaller molecules can be monomers, and then they can form these gigantic monstrosities. I mean, just huge, huge things. And that's basically, they're just putting them together. Aromatic. So you have your aromatic rings like this. Aromatic rings. Remember we talked about those? They have a smell. They're aromatic. In the early days, aromatic was used to describe fragrances. Now we know these are aromatic. We're just calling them aromatic. Aromatic. The class of compounds containing benzene-like rings. So aromatic rings, they're benzene. Okay, so the crazy thing about these. So here's mine. I'll just pop these guys off. Here's my benzene ring, right? I have some double bonds here, but what's really happening is these are all sort of sharing the double bonds equally. So it's not like this one has a double bond and then this one has a double bond. They could actually be anywhere. So what we do is we put this circle in there. We put the circle to say, hey, these bonds could be anywhere. And this is specific to a benzene ring. Each carbon-carbon bond is an intermediate between a single bond and a double bond. It's not really a single bond. It's not really a double bond. It does its own thing. This is called resonance. You will actually see sometimes resonance chemistry talked about, and this is resonance. Okay, so this is like where it is, makes a difference, and you can see how that's going to get crazy, where the electrons are, all kinds of fun stuff. So each carbon-carbon bond is not really a double bond, it's not really a single bond, it has its own sort of thing happening called resonance chemistry. Now, when you have these rings, they are a phenyl group. So when you're numbering it, you have a 1, 2, 3, remember making it the smallest one, 3 phenyl heptane. So that's a little bit of a good time. Don't forget that these benzene rings, write this down, or I'll write it for you in the last 20 seconds, see if I can do it. They are nonpolar. What does this mean? It means they're insoluble in water and they are flammable. So write that down. Okay, I have 5 seconds. I think I got it all. Bye. See you in class.